Welcome back, everybody. We're going to go through practice exam number 2. We're going to run into a weird problem number 4 here in just a moment. But let's get started. A bag with 6 marbles is shown below. 3 marbles are yellow, 1 is red, 2 are blue. A marble is chosen from the bag at random. What is the probability that it is not yellow? All right, so we're looking for probability not yellow. First of all, my denominator is going to be 6. I know that because there's a total of 6 balls in here. Now, how many of them are not yellow? I am seeing here, here, and here. So I'm seeing 3 of them. Now, in ALEKS, you can leave it as 3/6, or you can reduce it to 1/4, 1/2, sorry. So either way is fine. Not too bad. A bag contains 8 tiles labeled A through H. 1 tile will be randomly picked. What is the probability that you're picking a vowel? So probability vowel. First of all, my denominator is 1, 2, 3, 4, 5, 6, 7, 8. 8 letters total. And how many, vowels are there? I'm seeing here. I'm seeing here. I'm just seeing 2 vowels. And again, you can leave this unreduced or reduced. Both answers are acceptable. Oh. All right. If there are any questions or you need me to slow down or whatever it is, just let me know. I'm happy to help. All right, number 3. A drawer is filled with 3 black shirts, 8 white shirts, and 4 gray shirts. Before I do anything, I'm going to add those up to get my denominator. And that looks to me like it is 15. Okay, it says 1 shirt is chosen at random from the drawer. Find the probability that it is not a white shirt. Now, we could do this using a complement rule, but I'm not going to. These numbers are small enough, it's not that big of a deal. My denominator is 15. And how many shirts are not white? That's going to be 3 plus 4. The 3 black shirts and the 4 gray shirts. And they asked us to leave this as a fraction. All right, number 4, for whatever reason, I could not get my PDF to do this, so I have to switch to here. And we're going to actually do it. You may want to take a screenshot of that or something as we're going through. So we have a coin is tossed 3 times. We have all the outcomes here. There are 8 outcomes. So my denominator here will be 8 every time. Event A, a tail on the first toss or the second toss or both. A tail on the first or second toss. Here, here.
Is your sound muted?
Am I muted? No? Can you guys hear me?
Yeah.
Oh, okay. A tail on the first or second. So we're here, here, and here. Wow, that's quite a few. That's wow, 6. 6 out of the 8. Again, you could reduce that, but it's not necessary. Exactly 1 head. Seeing here and here. That's looking like 3 out of 8 to me. Alternating head and tail with either coming first. Okay, so just purely alternating. So I'm seeing here. No, 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 yes. Oh, I'm just seeing 2. 2 out of 8. All right. Any questions there? All right, so now I'm going to switch back to my iPad.
Does the practice exam change if you do it a second time or a third time and a fourth time?
I believe so.
Okay.
Once you get it correct.
The correction, if you get the question, like that one stays that one changes, or
the question type stays the same, the numbers would be different, or maybe the scenario might be slightly different, but the type of question would be the same.
okay.
All right, question 5. Reina rolled a number cube, I'm assuming that's a 6-sided die, 25 times. There's my denominator, and got the following results. And so I want to make sure we understand what this table means. So of the 25 times, she rolled a 1 7 times. She rolled a 2 3 times, a 3 3 times, a 4 3 times, a 5 3 times, and a 6 6 times. So we are going to say from Reina's results, compute the experimental probability of rolling an even number. Again, my denominator is 25. And how many even number, or how many of them were even? Let's go through this. So here, here, and here. So that is looking like 12 to me. Out of 25. And they want us to round to the nearest thousandth. So let's see what we get. 12 divided by 25. 0.48. Because it says thousands, you can put a 0 at the end of that if you want to. Assuming the cube is fair, compute the theoretical probability of rolling an even number. Well, now we're looking here. There are 1, 2, 3 even numbers out of the 6. And we can see the 2 actually are pretty darn close, which is expected. Part C, assume that the cube is fair, choose the statement below that is true. As the number of rolls increases, we expect the experimental and the theoretical probabilities to become closer. That's true. That's exactly what we're going to expect. So instead of 25 times, if I did it 50 times, I would expect it to be even closer to 0.5. I'm going to read the other 2 options. The experimental and theoretical probabilities must always be equal. That's never true. Almost never true, I should say. As the number of rolls increases, we expect that the experimental and theoretical probabilities to become farther apart. That's definitely not true. So they should be getting closer and closer and closer to each other. Number 6, we have some Venn diagrams here. A college radio station surveyed 337 incoming freshmen to see how many like classical music and how many like rap music. I kind of joked with my other class. I don't know very many freshmen today that are into classical music. I know I certainly wasn't so much when I was young. All right, so here we go. Part A. How many of the freshmen like rap music? So that's going to be the 68 plus the 77. So 145 is what I'm getting. But there's a long delay here. I'm going to try to redo this. Come on now. All right. How many of the freshmen like classical music or rap music or both? So that's going to be all of those. This here. And lastly, how many of the freshmen do not like both classical music and rap music? So that's going to be everything but right there. So that's going to be the 119. 119 plus 77 plus 73. And these are my answers. By the way, if you see me make a mistake, please speak up. Try to be as accurate as I can here. Any questions there? All right, Fran the Fearless has a well-known act at a local zoo. As part of the act, Fran handles a scary animal that she picks at random out of a box of terror. The following animals are in the box: 10 poisonous snakes, 5 non-poisonous snakes, 8 poisonous spiders, and 6 non-poisonous spiders. What is the probability that the animal Fran picks is poisonous or is a snake? All right, so probability, poison, or snake. This is going to be the probability poison plus the probability that it's a snake minus the probability of poison and snake. And I'm going to start by trying to find how many animals are in the box total. So we have 10 plus 5 plus 8 plus 6. So my denominators can be 29. All right. All right, so how many of the animals are poisonous? There are 10 poisonous snakes, and there are 8 poisonous spiders. How many snakes are there total? There's the 10 poisonous plus the 5 non-poisonous. And how many are poisonous snakes? That's going to be 10. Notice I used the 10 twice on this one. That's why we have to subtract one of them out. We double counted that. And that is, they want to store it into the nearest hundredth. Zero 0.79. Let me pause there for a second, make sure we're all good. Any questions I can help with? All right. A marble is selected from a bag containing 8 marbles, numbered 1 through 8. So our sample here is our sample space. This is everything. Event A, the marble selected is an even number. Event B, the marble selected has a number greater than 3. So here are our two events. Right, it says event A or B. Now, or means that we are all inclusive. So that's going to be a list of 2, 4, 5, 6, 7, 8. This is the or scenario. Part B is the and scenario. So which numbers are on event A and B at the same time? I'm seeing 4, let's see, 4, 6, and 8. This is the more exclusive group. And part C is the complement of A. A is even numbers. That means the complement of A must be all the odd numbers. How are we doing? All right. A spinner has 20 equally sized sections, 18 of which are green, 2 of which are blue. The spinner is spun. At the same time, a fair coin is tossed. What is the probability that the spinner lands on blue and the coin toss is tails? So probability blue and tails. Well, for the first one, my denominator is 20, and how many of them are blue? Just 2, it looks like. And what's the probability of getting a tails? That's going to be 1 out of 2. And they say do not round your answer. I don't think we will need to. So 2 times 1 is 2. 2 times 20 is 40. Here is my answer. All right. Number 10. Looking good. A university class has 22 students. 6 are psychology majors, 4 are history majors, 12 are art majors, and each of them only have 1 major. The professor is planning to select 2 of the students for a demonstration. The first student will be selected at random. Then the second student will be selected at random from the remaining students. So this means that we are not replacing the student. So, probability both history. So the first one is going to be out of 22 students. And how many history majors? There are only 4. And once that one is chosen, there are now only 3 history majors left to choose out of the remaining 21. So I multiply the numerators, divided by multiply the denominators. Be sure to use your parentheses, be extra careful. So let's round it to 3 decimal places. Here we are. All right. Yeah, and so it continues to go down because we're not replacing. Number 11. We have a deck of 8 cards numbered 1 through 8. Some are white and some are gray, as shown below. Answer is a fraction. A card is drawn at random. Part A. Let's write this up here. Part A. What is the probability that the card drawn is gray? Okay, well, first of all, I'm not sure why they're spelling it the British way. That's fine. My denominator is going to be 8. And how many of them are gray? It looks like 5 of them are gray. And they want it left as a fraction, so there we are. Part B says, what is the probability that the card is gray given that the number drawn is less than 7? That is going to be the probability, or I'm going to make it the number of gray and less than 7. All over the number of numbers that are less than 7. How many gray numbers are less than 7? I'm only seeing 4. And how many numbers are less than 7? 6 of them are. And once again, you can reduce that if you'd like, but it's not necessary. So you could put 2/3 if you want. Yeah, keep an eye out for those givens scenarios. All right, I'm going to add up all around the outside. See, this is 23, this is 27, this is 20, this is 30. We may not need all that information, but it's there if I do. All right. At school's open house, t-shirts and sweatshirts were sold. Each item was purchased by either a student or a parent. And here's the table that summarizes the 50 items. There's my N, 50, for some of these problems. All right, so we have part A. And I'm going to write part A up here. Probability that a random shirt is drawn and they want them as decimals, it's a t-shirt. All right, so out of the 50, how many of them were t-shirts total? That's going to be 30. But a 60% chance of randomly selecting a t-shirt. All right, part B. Put down here for that. Actually, part B I can put here. Probability it's a student and t-shirt. Again, that's going to be out of my 50. And how many students bought t-shirts? That is 12. All right, part C. Probability student given that we're looking at t-shirts. It's going to be the probability of student and t-shirt. And I'm going to make this N again. Of the number of t-shirts. So student and t-shirt, that is 12. And the number of t-shirts is 30. Wow, that is really delayed. I'm gonna try to reconnect it again. Snap for a second. Come on now. Is that still real tiny for you guys? There. What's with my connection today? All right. The gender and year of each of the 195 students in a high school band were recorded. The data is summarized in the table below. What is the probability that the student is male or a sophomore? Oh, you know what? This one's messy. I forgot. So this one's the probability male plus the probability sophomore minus the probability of male, come on, male and sophomore. So probability male, how many males are there? Let's see, we got 24 plus 17 plus 17 plus 28. 86 out of the 195. Number of sophomores, 17 plus 14. 31 out of 195. Minus the male sophomores. How many male sophomores are there? There's 17. And nearest hundredth, 0.51. What is the probability that she is female? Well, 86 are male, so I'm going to cheat a little bit. 195 minus 86. So this is going to be the probability. This is going to be 109 out of the 195. So I just did the complement of the male divided by 195. All right. We are to counting. Kennedy High School is going to select a committee. The committee will have a faculty member, a male student, a female student, and a parent. And here are the potentials. So this is just multiplying across. So there are 3 faculty members. There are 3 male students. There are 3 female students. And there are 1, 2, 3, 4 parents. (108) committees. All right. I don't see anything in the chat. Looking good. Answer the questions below. Part A, 77 athletes are running in a race. A gold medal is to be given to the winner, silver to the second place, and a bronze to the third place. Assume that there are no ties. In how many possible ways can the 3 medals be distributed? Now, in this case, The order matters. So we are going to be using permutation. So in this case, there are 77 permutation 3. So if you remember, this is, you hit math, you go to PRB up top there, probability, and there's my NPR. Some of your calculators, you need to have already typed in the 77. My particular one does not. All right, this many ways. Part B, a certain committee consists of 16 people. From the committee, a president, vice president, secretary, and treasurer are chosen. So again, the order is going to matter for this one. Now, I want to do a disclaimer. That doesn't mean on the test that they're both going to be permutation. It's possible they could both be combinations. It's possible one of them could be one of each. So this one just happens to be permutation. This is going to be 16 permutation 4.
Is there a trick to knowing if the order matters, or is it?
You just have to read each question carefully.
Okay.
Yeah, there aren't like trick words and things like that that are going to be indicators usually. But usually when they say, you know, for one of them, it's going to be this characteristic, and for another one's going to have a different characteristic, that usually means that that's permutation. The combination is going to be when it's just, I just need 5 people out of these 12.
So if it says there's like a special condition, is that permutation?
Often, yes.
Okay.
You can see how non-committal I'm being with my answers.
Yeah, often, yes.
Because as soon as I say yes, it's every time, then someone shows me a counterexample of that, and yeah. These are this many ways. All right. A weighted number cube has faces labeled 1 through 6. This is a die, which is singular of dice. Let x be the number shown on the cube when it is rolled. Here's the probability distribution of x. Meaning 17% of the time they've rolled a 1, 29% of the time a 2, 16% of the time a 3, and so on. Find the probability of the number described as shown on a random roll, that it's less than or equal to 2. So we are looking for, in this case, these down here, less than or equal to 2. Higher than 4. That is just going to be here and here. Does not say it's including 4 in this case. Hope we're doing okay. Not all visitors to a certain company's website are customers or potential customers. In fact, the company's executives estimate that about 10% of all visitors to the website are looking for other websites. Now, I flubbed this one a little bit earlier. So 10% are looking elsewhere. That means 90% are looking for the company's website. And part A says, estimate the number of visitors in the sample who are actually looking for the company's website by giving the mean of the relevant distribution. So mu, this is a binomial distribution, is n times p. P in this case is the 90%. Quantify the uncertainty of your estimate by giving the standard deviation of the distribution. Round your response to at least 3 decimal places. So sigma is the square root of n times p times q, which for us is going to be 50 times 0.1 times 0.9. Let me rewrite that. It says round response to at least 3 decimal places. All right. And you, of course, can have all these formulas with you during the test. Number 18, a machine that manufactures automobile parts produces defective parts 16% of the time. If 8 parts produced by this machine are randomly selected, what is the probability that fewer than 2 of the parts are defective? So I'm going to write out the, sorry about that. And they want fewer than 2. That means here's what we're looking for. This is a binomial distribution. And thankfully, x in this case is less than 2. So there are 8 trials. Probability of success is 0.16, and we want 1 and down. Remember, we go to second, then vars. Scroll down to binom CDF. 8, 0.16, 1. And they want to 2 decimal places. 0.63. Yeah, anytime it says anything about intermediate computations, we don't have any intermediate computations right now. So you can ignore that. Number 19. Find the z value that corresponds to the given area in the figure below. All right. So this is a normal distribution. And remember the norm CDF, I see something in the chat. Would the exam be 26 questions as well? It will be no more than 26 questions, most likely be a little bit less. I always make my practice exams a little bit bigger than my regular exams. All right, so this is going to be normal CDF. And this is starting, I'm sorry, this is inverse norm, pardon me. Inverse norm, because we already have the area. We're looking for the position on the z-axis. And this is going to be 1 minus 0.4025. Now, a discussion came up before. Some of the newer TI-84s have the option of right. Hey, America, did you have a question?
No, I joined from my phone because my mic doesn't work.
Okay. Oh, I see. It's I'm going to always teach it as though it's going area to the left. So if it's area to the right, I'm just going to do 1 minus. So I would recommend you always keep it on the left part of your calculator unless you're really confident and understand what the left, right, and center actually means. So let's see what we got here. All right. Had to get a commercial. All right. So inverse norm of 1 minus 0.4025. Now, this picture is nowhere close to what actually is happening here. And we're going to round to 2 decimal places, I think. 4, pardon me. So 0.2469. Now, the reason I'm saying that this picture is not right, because this is almost 50%. And remember, 50% is going to be way over here at 0. So it's more likely that a more accurate description of this picture would be here. Oops, that's the area. This is 0.25, I'll say. So we're really close to 0. So it doesn't surprise me that the area is going to be close to 50%. But the actual answer that we're looking for is here. All right. Number 20. In the standard normal distribution, find the z-value that corresponds to a 99 percentile. All right, I'm going to draw a picture. If you remember percentile, that is the percent to the left. So this area here, 0.77. So this is definitely going to have me use inverse norm. And that is going to be 0.77. And that actually is this position. Oops. This here is actually where this is going to go right there. That's the z value right there. That was number 20. Number 21, find the probability using the normal distribution. It says probability that z is less than negative 0.98. Let's see what that picture is going to look like. It's negative, so it's over here, negative 0.98. So that's going to give me, they want less than, so that's over here. So that is going to be, Jalea, your mic is on.
Oh, sorry.
That's okay, no problem, just want to let you know. All right, so we are going to use inverse or norm CDF. And this is going to be negative 99999. I see something in the chat. Well, that's. Nope, you're good to go, Jenna. Everything's in Canvas that you need to know about the test. And up to negative 0.98. So this is about 0.1635. And what we're saying is that this area right here, 0.1635. All right. Number 22. Find the area under the standard normal distribution curve to the right of 2.28. Okay, so that is going to be here. 2.28 is going to be way, way, way out here. So we are going to be using normal CDF. And that is going to go from 2.28 to a really big number. Now, I want to predict that this is going to be a tiny, tiny area because we're way more than a good amount of more than 2 standard deviations away from the mean, which is a lot. So here we go. So here we are, a little over 1%. And I'm saying that this is that area there under the curve. All right, Jenna, take care. All right, number 23. Doctoral student salaries. Full-time PhD students receive an average of $12,837 per year. If the average salaries are normally distributed with a standard deviation of $1,500, find the probabilities. All right, part A. Student makes more than $17,000. All right, so this is part A. So we're going to start here. This is in dollars. We're going to be way over here. So that is going to be normal. CDF. That's not going to fit there. Let's write that down here. So normal CDF. That's going to be 17,000. And make sure this is a very, very, very large number here, because 17,000 is quite large itself. This is 12,837 and 1,500. But not very many are making more than $17,000. In fact, less than 1%. This is part A. Part B. And this is going to be between 15,000 and 16,000. Now that's crazy way too big, but we get the idea, I think. And this, once again, is in dollars. This is going to be normal CDF. 15,000, 16,000. And the mean standard deviation Let's see what we get. So almost 6%. Come on. All right, that is number 23. A normal CDF. Police Academy acceptance exams. In order to qualify for a police academy, applicants are given a test of physical fitness. The scores are normally distributed with a mean of 68 and standard deviation of 10. If only the top 21% of the applicants are selected, find the cutoff score. So once again, let's graph this. And there's no unit to these. So this is 68, and they want the top 21%. So we're going to be using inverse norm. Of 1 minus 0.21, because we only know area to the left, comma 68, comma 10. So this is the mean and the standard deviation once again. And that's going to give us a cutoff score of about 76. So a score of a 76 or higher is going to qualify you for the police academy. All right, we are almost done. A survey found that the American family generates an average of 17.2 pounds of glass of garbage each year. Assume the standard deviation of the distribution is 2.5 pounds. Find the probability that the mean of a sample, here is where we have to be extra careful, a sample of 50 families will be between 17 and 18 pounds. Assume that the sample, okay. So here's what this means. This is going to be between 17 and 18, so this is going to be normal CDF. Between 17 and 18, with a mean of 17.2. Now, our standard deviation is going to change now. Remember, it's this. And n in this case is the 50. So this is going to be the 2.5 divided by root 50. So this is the central limit theorem. So we have to change that standard deviation. And it's quite high. All right. And we're to the last question. An average teacher's salary in a certain state is $57,337. Suppose that the distribution of salaries is normal with a standard deviation of 7,500. All right. So part A says, what is the probability that A, meaning 1, randomly selected teacher makes less than $50,000 a year? So that is going to be, oops. And we don't do anything to this standard deviation because we're only dealing with a sample size of 1. So divided by root 1, which doesn't change anything. And it turned into almost a turquoise. That's kind of cool. So no problem with that. However, part B changes things. Part B says if we sample 80 teachers' salaries, what is the probability that the sample mean is less than $55,500? So now we have a sample. Which means my standard deviation is going to change. So this is going to give us normal CDF. Once again, you'll note that the standard deviation has definitely changed. So we have to adjust that standard deviation.